Hey, thanks for joining me again. So this is a simple item I sell on Etsy currently. It's a screw cover cap for the grab handles on a Sprinter van by Mercedes. My in-laws had a problem where they pop out, and apparently it's a very consistent issue on new vehicles where they always pop out. So currently I 3D print them, get a really nice surface finish on them, and then sell them. But what I want to explore on this is actually taking the current design for 3D printing, adding the proper draft angles, adding some features for injection molding, creating the cavity and core out of a 3D printed mold, creating that injection, and actually seeing how that comes out, how we look now, and what we can do to improve this part and actually make it, a production worthy part in the future using inexpensive tooling. So get comfortable and follow along as we create this product. So the first step in this process is create the sketch, and then I actually revolved it around to create the cylindrical shape here. So then the next simple thing we did was add a radius to this top edge just to break it a little bit. And this is in the original part design. So far nothing is new for injection molding, but that's about to change right here. So this is actually the draft feature that we add. So if you look at the bottom side of that cap, that is what we would call the pull direction, or the face that we're going to be selecting, or the pull direction, which determines where that draft starts. So if you think about this, if you're pulling this cap out of the mold, you want to make sure that the angle is not directly perpendicular, and definitely no undercuts to get caught inside that mold as we pull it. And then we're going to go ahead and do the same thing for this inside surface here. On the injection molded, the 3D printed molds using resin printers, it's generally a good idea to have a minimum of about 3 degrees of draft. Other people might have other ideas. So please leave a comment down below if you have a recommendation for a better rule of thumb. But 3 degrees is something that seems to be a fairly easy to work with number. And next we're going to go ahead and add some rib features to this part. And this is also from the original part, but I kind of went through and rebuilt a few of these features just to make sure that every single piece of it had draft. So when it pulls out of that mold again, we want it to get looser the higher it pulls up, not tighter. These ribs are actually what make it better than the original Mercedes design part. So these are really small features around the perimeter that are designed to crush as they go into the grab handle that they're covering the screw for. That way you can be a little bit loose on your tolerance for the diameter, as well as Mercedes can be loose on the tolerance for the diameter of their parts, of their mating parts, and we can still have a tight fit, a snug fit, and something that's not going to fall out every single time it's used when it's on the field. So here it was kind of goofy when I had multiple features, the radiuses and fillets and everything on that part when I created that rib. So I ended up kind of cheating, and I added the rib, and then I rotated the entire body, including the cap itself, and created three circular patterns on it, and then I merged all those parts together. So that's a little bit of a goofy way to do it, but I've had times where I get so frustrated with it that I end up not even making the part. So this is a little cheat to help you get around that. So that's pretty much it for creating the majority of the part and creating the draft angles that allow it to pull from the mold. But one thing I will encourage is look at the radiuses and fillets on here. So injection molded parts do not like to be pulled out of sharp corners. So anywhere you can, add a small radius. The bigger the better, but not everything can have a radius on it. So make sure you're adding those radii on there, and that will ensure your part is stronger. You're not going to create stress risers as that plastic is injected and actually trying to roll through the entire mold. So congratulations are in order. Now we have a part that's ready to be built into a mold, but how to get this into a mold on a budget? First, thingiverse.com, look up Buster Beagle for this specific thing. If you bought the mold frame from Buster Beagle or a similar site, I just go into thingiverse.com, type in Buster Beagle. I'll provide a link down below as well. And he actually has a mold template. And the amazing thing that he did is he has all the tapers in there so it stays in the mold frame, but also he shows where all the sprue locations are. So as you're building your part into this mold, it's easy to tell where you want your sprue, where you want your gate, how this thing is going to be assembled. So after you download it, you're actually gonna have to go to insert mesh, find your two products or your two molds that come in. Fortunately, the orientation that they import already brings them in perfectly in relation to one another. So make sure when you're moving these parts, you're moving both of them at the same time, because if you just move one, then it's probably gonna be a pain to realign both the top mold and the bottom mold. And then if those aren't aligned, then your part's gonna have a crazy off-shifted parting line. So make sure that the proper component's selected while you're moving, and that'll make it a lot easier. What I'm doing here is just making sure that both halves of the mold are lining up exactly where that parting line is. So just above the radius of that top cap section. So everything that pulls up can go up, everything that pulls down can go down. We want to make sure that we're aligned left to right, right to left. The angles are aligned, and we're also lined up with that sprue and the gate. And at least with the way I designed this, I'm not thrilled with the way I designed this gate. There's no cold slug well, there's a lot of features that are lacking for proper mold design. But this is my first go. I was just super excited to try and print something, and I made a few shortcuts and they end up biting me later. But this is just kind of an overview showing how we do it. So the first part was importing the mesh. Second part is positioning that mesh in relation to your part. Where do you want that part? And then part number 3, I guess, right here is where we are actually going to say, how do we want our gate to interact with that mesh? So we're gonna go through and we're actually going to design the rest of the sprue, and that sprue is going to align with that sprue hole that Ryan over at Buster Beagle already designed into his mold cavity and core that you can just download. So I just basically continued his design through. I drew half of it, and then as you'll see in a second, I'm gonna revolve that. I'm not revolving it, cutting out the shape yet. So that's something that's really interesting in the thinking behind how these are made. You're actually building the entire positive that you want for the mold in a positive volume. You're not trying to cut everything out, because if you start cutting things out, it just becomes a real pain to work with. So I'm creating that sketch for what I want my sprue to look like. I'm gonna go ahead, I'm gonna choose that top line there that I want everything to rotate about. You see me trying to struggle finding that line. So now that's my final sprue design. No real rhyme or reason why the angles on the front are that exact angle, because this should go into a cold slug well, which I'll talk about in another video. But I just rotated around there. And now I have to go and actually build a gate. So I went ahead and just chose some arbitrary dimensions that aren't gonna look too big on the part. You want it to be as small as possible to fit into an edge of a part on a non-cosmetic surface, but as big as you can get away with. So I simply created another little solid here, if you can see that box there. And I think I joined them with that sprue, and eventually I'll show joining with the part. But right now it's just joining with the sprue. So you can see now I have my part, my gate, my sprue. But one thing that is critical with injection molding, especially if you have tight tolerance parts, is not forgetting about the shrinkage. So plastic is a compressible product. It's not like water, it can compress. So what I go to when I was doing injection molding is a website called MatWeb. So I was just using standard polypropylene. So type in polypropylene MatWeb, scroll down, you're going to see quite a few numbers there: linear mold shrinkage, temperature, melt flow, all these things. So you're seeing 0.6 to 2%, 0.6 to 2%. Remember, this is in centimeters per centimeter, not percent, so you have to multiply everything times 100. So the average value, if you look at this over on the right, is 0.128 or 1.28% in the mold shrinkage, if I'm not mistaken. So I want to take that value that I got from MattWeb, shown right here, and I am actually, we're going to choose the 0.175 or 1.75% if you multiply times 100 to turn it into a percent. So I'm actually going to take that value and I'm going to take the size of my cap, doesn't matter the runner and the sprue, and I am going to scale it, and I'm going to do 1.01, multiplying it times 1 plus the percentage that you want to increase it. So now my cap is actually larger. Remember, I haven't cut anything out of the cavity and core of the mold, so I want to enlarge it to account for shrinkage, and then I'm going to go ahead and use Boolean operations to say I want to take this mold and I would like to subtract the cap out of it, and then I want to take the other half and I would like to subtract the cap and the runner out of it. And then basically when we inject from the frame, that is going to give us the final void to fill. And so as the plastic comes in, it's going to run through the runner, through the gate that we've designed, through the cap, cavity, and core. And there are a couple extra things that I'll point out later that I missed on this design, but ultimately it worked. So one key feature here is creating this mesh into a solid, because you cannot subtract a solid from a mesh. It just doesn't work. These meshes are all just triangles when you download them from Thingiverse or most STL providers. So you want to go to Modify, Convert Mesh, click on the mesh, Parametric, and that actually works for both of them. So that, after you do that, you can go back to your solid editing features. You go to Modify, Combine. We're going to say our target body is our mold, our tool body is these 3 parts. And I think I actually have to do them one at a time here. I'm not super familiar with how to do this. This is one of my first times doing this. But we go ahead and we actually basically delete whatever fills this from that mold. And then, as you'll see in the next part here, we actually check Keep Tool, because I want to be able to open this and I want to be able to see what my actual tool looks like. So if I want to see what the mesh looks like, what the cavity and core of the mold look like, I can go ahead and you see I actually selected the wrong one there. Target bot, I selected the bottom mesh, not the top mesh, or the bottom mold section, not the top mold section. So I just was looking at the wrong one here when I hid the other one. But when you subtract all this, you're going to be able to see a nice cavity and core as long as you hide the right objects. So that sprue is not actually there, that's a completely separate body. But you can see now, once I've subtracted the part, that is what the plastic will be filling in. And that's also been enlarged by that, 1.28% or something like that. So multiply times 1.0128, sorry. And that gives you the actual size that it needs to be before it shrinks. So do the same thing on the other side, and that, we're subtracting, we're doing a combine operation, we're doing the target body as the mold, tool bodies as the 3 features that we created, the gate, the sprue, and the part. And that leaves us with a nice, pretty section on the mold. So then I went ahead and imported both halves of the mold into my 3D print software, made some small supports to hold it in place, decided to print it upright to get the best resolution. Go ahead and click print, and then go ahead and click print 2 more times. Yep, play. Okay, nope, doesn't like my gloves. Play again. All right, after printing, I went to sleep. Came back the next morning, showing still 63% gray. Oh, it's not moving. Oh, no. So not only did my print freeze, but it actually broke off the supports. So it's a pretty big part, and I'm still learning resin prints. This is the Tech Sculpt ultra high temp product. I'll list that in the description below. But the printer actually freezing, I believe, saved me some resin rather than just running all night, curing the rest in that vat. So I ended up actually having to scrape the resin out of that vat and then restart again. When restarting, I decided to put the parts completely on the build plate, separate them a little more, and add some really massive supports. I figured these are not the mold surfaces, so I was gonna go ahead and make sure that this part did not move off that build plate. So print number 2 went much better, came back at the end of the workday, and everything looked great. It was really clear, it was stuck to the build plate fine. You had a little bit of the elephant's foot where it sticks to the build plate, but after washing it for a few minutes in isopropyl alcohol, went ahead and put it in the UV curing station. I put this on for 15 minutes. It did yellow it significantly, but I'm also not sure what the appropriate amount of time is. So if anyone, I find lots of different answers when I try and research this, and I think it depends on the curing station, depends on the resin, the thickness of the part, etc. So if anyone has recommendations, please let me know. So when pulling it off the curing station, didn't look nearly as pretty as before, but you could still see a lot of detail in the features. My ribs are there, the cavity and core, both sides are there. The gate looks clean, the sprue looks clean. So I went ahead and took apart my mold base, mold frame, I should say, and tried to fit my brand new part in there. So it actually flips over, make sure the sprue holes line up. And to start, it was a little bit stiff, so I actually needed to file down the edges a hair. But after screwing it all back together, you'll see in a second, it still did look like there was a little bit of a gap between the faces of the mold frame and where the parting line faces were actually going to line up. So from the very beginning, I knew this wasn't the perfect mold, but this is again an exercise. One of the things I really encourage is just get something done. You can learn, you can iterate, but the faster you can prototype, the better you're going to be at creating better iterations every single time you go through. And that's one of the reasons I've actually purchased this entire system. So here we go with our first shot. Everything is pretty close to aligned. I'm actually PID auto tuning right now, so not a great idea to do this. Also have the hopper a little over full, so I might take a couple plunges to get that in, but we really want to try this. So let's go ahead and give it a shot. Looks cool. Guess is failure, but we'll see. Yeah, kind of what I was afraid of. The gate, if you can see that. So it didn't even make it into the gate, but I'm not sure if that's just temperature related or it takes a couple shots or air pressure. So we'll keep playing. Turns out it was actually a combination of all three. Looks like it filled the part more though. Oh yeah. That's something. So the more we did, the more processes and temperatures we changed, some short, some overfills, some expanding. It's really a trial and error process, and especially while you're learning. So that's why we're here. That's why we're trying to figure out how to make this work. I'll get more into details on how, to set up the system later. So exact temperatures and pressures and all. But right now, this is just to show you what the first shots on this machine look like. Thanks so much for joining me, and hope to see you on the next video.